Okay, we're going to do a lot of physics type problems this semester. You really just have to memorize. You got to know that if you have position, velocity at time t is the derivative of position. Velocity is change in position per unit time. And then acceleration is the derivative of velocity. Acceleration is how quickly is your velocity changing. Or in other words, the second derivative of position. So we're given some position function here. Let's find velocity. That will be s prime of t. That will be the limit as h approaches 0 of s of t plus h. My independent variable was t here instead of x. We might also call this, by the way, I've mentioned this before, s dot. Dot means derivative with respect to time. It means your independent variable is time. And we might call the second derivative s double dot. Or, like we said a second ago, v dot. Acceleration is the derivative with respect to time of velocity. Okay, let's calculate this. So I'm going to replace all of my t's with t plus h. So that'd be 3 t plus h squared minus 4 t plus h plus 1 minus, and then from that I have to subtract the entire original in parentheses. If you don't put these parentheses, bad things are going to happen. That's a t. And then don't forget all over h. All right, and then let's clean this guy up. So that's 3 t squared plus 2th plus h squared. Distribute that 4. And distribute this minus. I know my t's and pluses look too similar sometimes, and I apologize for that. That's all over h. Distribute that 3. So 3t squared plus 6th plus 3h squared. And I just got to write all this stuff again. All over h. Don't forget your over h. Everything after that minus sign right there should cancel out if you got a polynomial every single time. 3t, negative 3t, negative 4t, positive 4t, plus 1, minus 1. Everything that's left on top should have an h in it. If something's left that doesn't have an h in it, you've done goofed. So I got that guy, and that guy left. All over h. And then I'm going to skip one of the steps here. Factor out the h and cancel, or you can just kind of cancel from each of them. You cannot do this. It doesn't just cancel one, it cancels one from each term. We get 6t plus 3h minus 4. And then finally, our last step every time is actually take the limit by plugging in h equals 0. I don't have to write limit anymore because now I'm doing the limit. So we get 6t minus 4. So my velocity as a function of time is 6t minus 4. This was my position function. I'm throwing a ball in some kind of parabola. Here's my derivative, the velocity function. Now, if we want acceleration, that would just be the derivative of velocity. And I'm not going to go through the whole using the definition of derivative here. You should try that on your own and check, and you'll just get 6. Now, what will our units be here? Our original function's in meters. Our time is in seconds. The derivative is always change in y per change in x. I don't have y's and x's here. This is what's playing the role of x. I'll put that in parentheses. No, I lied. Put it on the wrong one. Time is what's playing the role of x here. Meters are what's playing the role of y. Derivative is always change in y per change in x. So meters per second. It's a velocity. It's in meters per second. What about acceleration? Acceleration will be in terms of change in velocity per change in time. So that'll be meters per second, which we'll usually write as meters per second squared. So we have a constant acceleration function here. Our velocity is some linear function, and our position is some quadratic. And this is always going to happen if you have a polynomial. If you keep taking derivatives, your degree will go down by 1 every time. And that's a good place to stop.